right, so in 14.2, we're going to be dealing with the simple and multiple regression models. So that is going to be equations. So we can talk about independent or dependent variables as explanatory and response. So explanatory meaning, this is what we're trying to go, this is what we're trying to understand, and what happens as a response, the dependent variable there. So we've got a y-intercept and a slope. This might look really familiar to way back in Algebra 1, y equals mx plus b, and that is exactly what this is. That's our slope and y-intercept, but they tend to use b plus mx. And we use beta for the population and b for the sample. So when we're interpreting the slope, the beta 1, if it's a positive relationship, our slope increases. Slope, you can think of slope as incline or steepness. So if our slope is positive, and we always read graphs from left to right, then it's increasing. We're taking steps kind of like up a mountain. And if our slope is negative, we're going down. You can think about a little slope person. And if the slope is 0, there's no incline at all. There's no steepness. So we're just kind of walking along a flat line. So this is really important here. We're going to be interpreting these. And so we always say for every 1 unit increase in x, so whatever that is, money, time, whatever, y, whatever y is predicted to increase on average by, and then that's your slope. Okay, so x is always increasing by 1, and y is always increasing by the value. You can think about this as like our slope, if you think way back, and if this isn't helpful, it's okay. The change in y over the change in x. And so if we have a value, whatever our value is, it's always going to be over 1 if we were to write it as a fraction. So our x is always by 1, and our y is always by whatever that value is. And when we interpret our y-intercept, basically that's saying when x is 0. So whatever x is, there's none of it, then that's what the value of y can be predicted. It doesn't always make sense in context, but we try our best. So when we're talking about a sample regression equation, so we're talking about y hat. So we use this, sometimes it's called a predictor equation, and we use lowercase b for those. That's the sample equation. So that's the sample simple equation is y hat there. All right, and we're going to be dealing with trend lines or lines of fit. And a residual is simply just the difference between a predicted value and its actual value. A predicted value would be on that trend line, and then the actual value would be, how far away is it from the trend. So just here, we've got our predicted or expected value of y. Our b sub 0 is our point estimate for the y-intercept, and b sub 1 is our slope. So in a simple linear regression, the following sample regression equation is obtained. Interpret the slope coefficient. So our slope always kind of has that variable with it. So it's a negative 17. So our slope is negative 17. And because we don't know what x and y is, we'll just say as x increases by 1, because it's always by 1, right? It's negative 17 over 1, y over x. As x increases by 1, y, and because it's negative, decreases by 17. Predict y if x equals 5. So y hat is our predictor. So when x equals 15, you just plug that in, type that right into your calculator, you get 691. So there it is again for you. Go ahead and give this one a try. Press play when you're ready to see the solution. All right, so now how do we actually get those coefficients ourselves? So first we're going to make a scatter plot. Why? Because we want to make sure that the data is actually linear. We don't want to use a linear equation if the data isn't linear. So we're going to make an Excel scatter plot, add the trend line, and then we're going to use the data analysis. Remember, you have to use Excel for this. Google Spreadsheets is not going to do it for you. And then we'll calculate this. So this is the directions here. Let's go ahead and give it a shot. So using this data here, let debt payments represent the response variable and income represent the explanatory variable. All right, so x is our explanatory and y is our dependent. X is always independent or explaining. So x is our income, y is our unemployment. Oops, sorry, debt payment. All right, so this is given to us like out of order. It's y and it's x. So what is the sample regression equation? All right, so we're going to go into Excel here to do this. And so we're dealing with debt and income, and I'm actually going to get rid of unemployment because I don't want to confuse myself. And debt was actually the Y, so I'm just going to go ahead and move it this way. So first I'm going to go ahead and make sure that I can have a linear trend line here. So I went to Insert, Scatter Plot, and then I'm going to add a chart element and a trend line, and I can see here that yes, I can see that this is linear. So now that I know that, all right, I'm going to go ahead and do my data analysis. So in here, we're looking for regression. And then my Y values are right there. My X values are right here. And I have my labels. All right, so it's going to make a new worksheet. And there we go. And the thing that I actually want to focus on here is right here. These coefficients. This is what I want, okay? The intercept is 210 and the income here. So I'm just going to grab these and move back into my power. All right, so now I've got these. So the sample equation here is going to be, and just in terms of Y hat, it's going to be an intercept here, an income. You can think of that as our slope. All right, so it's going to be Y hat 210.3 plus 10.44x. Now, if we want to do it in terms of the problem, remember that our x is income and our y is debt payments. So we would say debt, and we would add a little hat because it's our sample, 210.3 plus 10.44, and our x is income. So that is our sample regression equation. So now it wants us to interpret B1, which is our slope. So remember that for every x, so for every, and what's our x again? Our x is income. So for every, and it's in thousands, so for every 1,000, it would be $1, but because it's in the thousands, for every 1,000 increase in income, debt payments, what do we got here? Debt payments are predicted to increase by $10.44. Predicted to increase by $10.44. So now let's do the intercept. So an intercept is when x equals 0. So our x again is income. So when there is no income, the debt payment is expected, it's predicted to increase to be $210.30. Okay, the debt payment would be $210.30. Predict debt payments if income is $80,000. So we're going to use our debt sample, right? And remember it's in thousands, so we'll plug in 80. And when we type that into our calculator, we end up getting 1045.55. And that's all written out for you right here. We'll do one more example together before you do a problem on your own. So consider this following data. We're going to create a scatter plot. We're going to calculate these, and we're going to find the predicted value. All right, I've just put everything into Excel, so I would type all that into Excel. I'm going to grab these. I'm going to click Insert. They want a scatter plot, and it looks pretty linear, but I'm going to add a chart and just check out my trend line here, and there we go. They want us to calculate the equation, the intercept and the slope. So I'm going to go into Data Analysis. Regression. And my y's here, didn't need to highlight that ahead of time. My x's, and I do have labels, I do have the letters x and y. So it's going to make a new sheet for me. And what I care about is this coefficient right here. So I'm going to grab those coefficients and head back to my previous sheet. Where did it go? There we go. Oops. Let's move those right there. So those are the coefficients here. Remember, this is the intercept, and then this is the slope. So what we want here, what is the equation? So the equation here would be y hat equals, our intercept is 9.149 plus 1.462x. Okay, so that is our equation. And when they want letter C, find the predicted value. So we can just use this here. So 0.9149 plus 1.462, and x is equal to 10. Oops, looks like I made a typo there. There we go. 23.769. And so that is how you do that. If you want to see the work, here we go. First, I typed it into Excel to get all of that. And then go ahead and complete these U-tries. Press play when you're ready to see the solution. And when we come back, we'll do multiple regression models.